So let's see how we can now take this one step further and do some processing of this data using the usearch tool. So now I clicked away everything I had open here after demultiplexing. So now we have the FASTQ files here. Let's go and copy the script that we need. And again, let me just repeat some previous copying here because the script we now need is also in here. And it's called usearch pipeline.r, and I copy it here. Same as I did for the demultiplexing, really. So here we can see it. And if I go over to RStudio, it should now be here. Yeah, so let's click it open. I'm not going to go into the details here. It's written a lot here. And again, it's this settings section where you do the where you can edit and do some changes. And of course, where is the executable for this? I mean, we don't have the proper usearch installed on Orion, so this is a sort of the free version that I have installed, so you shouldn't change this. You can use my installed version. It's open for anyone to use. The metadata file that we are going to make use of is now exactly the one that was produced for us during multiplexing, the text version here, right? So it's in the same folder, no path here. It means this file here. The name of the folder where the FASTQ files are is of course now the same as we used in the demultiplexing. And now I also have a temporary output folder, and here I make it a special folder for this software. And the only reason I do that is because I want to run several tools, not only usearch, and all of them output something in their temporary folder that we might go and look into, and then it could be nice to have them separated, right? So I know where are the temporary files from usearch, where are the temporary files from data, and so on. So otherwise you could just have used this one, this existing folder here. So I think I actually delete that one now because it's empty and I don't want to use it again. And here are some settings. Trim right, that's how much do you take off the end of each read before you start merging them. So if we go look into this here we have this these HTML files from FastQC. Let me click one of these open again. So what I'm talking about now is to cut off at the end, at this end, right? The 3' end of the reads, because we can see the quality is getting poorer and poorer and poorer. And this is the R1 reads, and now you can imagine the same for the R2 reads, but if you reverse them, this is the region towards the end here that will overlap between the R1 and R2 reads. And of course, the poorer quality, the more difficult this is to merge. So if you can strip off some of the sort of bad end here, it's usually a good idea to do that. How much can you strip off? Well, that's where you need this information. How long are the reads? They are typically 200, almost 300 bases, 295, I think, the longest ones, right? And this should be the same for the R2 read as well. We can actually go into that file and have a look, and we can see, yeah, they are actually longer, 301. Yeah, that has to do with the removal of the barcode in the R1 read. They are a little bit shorter because they have this barcode sequence. But here you can really see how bad the quality is towards the end. So it's really a good idea to try to cut off the last piece here. And remember now that the reads are around 300 bases long. And also remember, if I go back here, the amplicons we saw are typically like 450, at least 400 or close to. So it means that the two reads, each being 300 bases long, if you merge them and together they become this long, it means that they must overlap with at least 150 bases or something along that line. So it means that the overlap region is pretty long here, right? And that again means that we can tolerate to trim away quite a lot without damaging that overlapping region. It doesn't get too short, because remember, for each base you trim here, the overlap region gets shorter, right? But 10 bases is at least not much here. So I leave it with 10 bases. The error probability is 1%, and this is usually a good choice because Illumina errors are usually smaller than 1%. But you could relax this if you don't want to filter out too much reads. This mean size, identity, and so on is something we rarely touch, right? And at the end, the number of threads. So here we now have, and now we are now going to using 10 threads in parallel for speeding up the computation, and that's possible with usearch. So the rest of the code I will not go into. It's you can do that if you like. It's not that difficult. It's our code that creates some shell code actually, and then execute it in the shell. But again, as we did for the demultiplexing, instead of running it directly here, which is possible, we use the shell script. And now I open the shell script again, and then you can see here is the call now for running this usearch pipeline. And then I should comment out this one because I don't want to run that one again, the demultiplexing. So now I leave it as this. And now I should note important. We need to put this back to 10 tasks up here because that must be the same as the number of threads here. So if the number of threads are 10 here, the tasks you ask for should be 10 here. These should always be corresponding values, right? Because it's how much resources you ask for in the Orion cluster. So let me just save this one, and then I go and start it just like I started before by just calling the shell script again. And now let's see if it's running. It's running again. It's the same name of the job. You could have changed that. I've been running for 9 seconds here now. And let's see if something happens. Yeah, we can see it has created the temporary output folder for usearch and probably started to fill it with something. Yes. And this we will not supervise sort of, but or monitor because it's yeah, you do it in case something goes wrong. But that's really it.